Let's say that P is our first point and S is our second. So we can say the gradient of PS is equal to 1 minus 3 over 1 minus 6. 1 minus 3 gives us negative 2 over 1 minus 6, which is negative 5. Now the negatives will cancel out, and we're left with a gradient of 2 over 5. The gradient of PS is positive, and the gradient of QR is negative. 2 over 5 is the reciprocal value of 5 over 2. So straight away, we can see that these lines are perpendicular, but this is not enough to prove. We need to show the product of these gradients is negative 1. So we can say the gradient of RQ multiplied by the gradient of PS, the gradient of QR, negative 5 over 2, multiplied by the gradient of PS, 2 over 5. Now the 2's will cancel, the 5's will cancel, and we're left with negative 1 multiplied by 1, which is equal to negative 1. So QR is perpendicular to PS. Let's draw a square angle at S on our diagram to show a 90-degree angle. And now we can move on to part D. Calculate the perimeter of triangle PQR and round your answer to 2 decimal places. The perimeter of a shape is the total length of all sides. So to find the perimeter of this triangle, we say P for perimeter is equal to this side, PQ, plus this side over here, PR, plus the third side over here, QR. We already know that PR and PQ both have a length of square root 58 units. Now we can use the distance formula to find the length of QR. Let's say that Q is our first point and that R is our second. And we can say the length of QR is equal to 6 minus negative 4 in a bracket squared plus negative 1 minus 3 squared, all under a square root. Now let's simplify the terms in the brackets. 6 plus 4 is 10, so we get 10 squared plus negative 1 minus 3 is negative 4 squared, all under a square root. 10 squared is 100 plus negative 4 squared is 16 under a square root. And finally, 100 plus 16 is 116 under a square root. And this is the length of QR. Now we have the lengths of all 3 sides. So we can say the perimeter of PQR is equal to PQ, which is square root 58, plus PR, square root 58, plus QR, square root of 116. And now we can put these values into our calculator. So we say the square root of 58 plus the square root of 58 plus the square root of 116 is equal to, let's put this to decimals, and we get 26,00. Now the question tells us to round our answer off to 2 decimal places. So we can write our answer as 26,00. 0.00 units. Let's put the length of RQ into our diagram, and now we can move on to part E. Calculate the area of triangle PQR. To find the area of a triangle, we use the formula: the area of the triangle is equal to 1 over 2 multiplied by the base multiplied by the perpendicular height. From our diagram and the questions we've already worked through, we know that QR is perpendicular to PS. So in this triangle, QR is the base and PS is the perpendicular height. We already know the base QR is square root 116 units in length, but we still need the length of PS, so we can use the distance formula. Let's say that P is our first point and S is our second. So we can say the distance PS is equal to 1 minus 3 squared plus 1 minus 6 squared, all under a square root. 1 minus 3 gives us negative 2. Put this into a bracket, squared, plus 1 minus 6 is negative 5. Put this into a bracket, squared as well. We put everything under a root. Negative 2 squared gives us 4, plus negative 5 squared is 25 under a square root. 4 plus 25 gives us 29 under a square root. We can make a note of this on our diagram as well. And now we can make some space and find the area of the triangle. So we say the area of triangle PQR is equal to 1 over 2 multiplied by the length of the base, root 116, multiplied by the perpendicular height, which we just found to be square root 29. Now we can take our calculator and we say 1 over 2 multiplied by the square root of 116 multiplied by the square root of 29 is equal to 29 units. So this is the area of the triangle, and we write it as 29 units squared. Let's do one last example.